increasing function. Now what do you mean by decreasing and increasing function? Now all of you look up here. If I have a function like this, straight line, can you see that as x increase, y also increase? That's an increasing function. Okay? But does it mean that it must be a straight line? No, it can also be like this, right? A curve is also increasing. Understand? Okay? Alright, now what do you mean by decreasing? That means as x increase, y decreases. Or it can also be like this. Can see it? That means as x increase, y decreases. Okay, now what has this got to do with the derivative? Okay, can you turn to page 28, all of you? A function y equals fx is said to be an increasing function for a given interval a b if as x increases, y increases in the interval. Okay, a function y equals to gx is said to be a decreasing function for a given interval x between a and b if as x increases, y decreases in the interval. Now how come they give us interval? Okay, how come they give us interval? Okay, let me just show you something here. Now first you look at this curve. Can you see that from all the way from that side until this point it is decreasing? Then from this point onwards is what? Increasing. That's why there must be an interval. Because sometimes it goes like that. You understand what I'm talking about? Can or cannot? Can, huh? Okay, good. Now next page please. The first row, they give you examples of increasing function. And the next row, they gave you the function of decreasing function. Examples of decreasing functions. Are you okay? Alright, next. Let's take a look at page 29, the last statement. Hence, it is important to state the interval when describing the behavior of the function. Like what I said here, the interval. It doesn't mean that the whole graph will be increasing. Okay, the particular interval that we are talking about. Everybody clear? Okay? Alright. Now, next. Look at page 30. There is some math symbol down there that they use, but they didn't explain. So I'm going to explain to you in case you do higher level of math. In general, we have the following. If dy dx is positive, okay, for all AB, now this is not coordinate. This implies that y equals fx is an increasing function in AB. Now, when we write like that, in maths, it means the x is between A and B, exclusive. If they write like that, right, it means inclusive. This is some math symbol. What if they write this nonsense here? What does it mean? Exclude A, include B. This is a mathematical symbol. It's not coordinates. Do you understand? This book assumes too much. You assume that you're very good in your maths and you read the books. Okay? Can or cannot? Can or cannot? Okay, so dy dx bigger than 0 means increasing function in the interval AB. dy dx less than 0 means it's a decreasing function in interval AB. Everybody clear? Everybody clear? Okay, yeah? Alright, good. So this is the main concept that we have today. dy dx bigger than 0 imply increasing function. Less than 0 imply decreasing function. This is what we're going to learn today. Everybody clear? Okay, now let's take a look at example 3. Example 3. Given that y equals to 4x cubed plus 3x squared minus 6x minus 7, find the range of values for x for which y is decreasing. Now, let me just warn you first. This question already says y is decreasing already. Am I correct? Okay, so first of all, dy dx, all of you, what's dy dx? 12x squared plus 6x minus 6, right? They already tell you it's decreasing, right? So that means dy dx must be less than 0, right? They already tell you, okay? So I'll have 12x squared plus x squared minus 6 is less than 0. I can divide drop by 6, right? So what do I get? Correct. This is a quadratic equation. Sorry, quadratic inequality. Okay. Do you know that I have this? Okay. So I will have a 2x minus 1, x plus 1 less than 0. Correct. Okay, must put in terms of vectors. Now, for me, right, I don't know what Mrs. Beck said, but for me, right, always make sure this is a positive. If this is a negative, I'll multiply drop by negative and make sure this one change. So I'll only draw U shape. I never draw N shape. Understand? This is to prevent you from making mistake. Okay, now let's take a look. This one, the answer is half, right? What's this answer? Negative 1, right? It must be less than 0, that means below the axis, right? So it's this range, right? So what is my x? So for this particular range, okay, y will be decreasing. Is that clear to everyone? Is that clear to everyone here? Okay, so the question says less than 0. So this will be the range of x for which y is decreasing. Everybody clear? Clear, huh? No problem, huh? No. Okay, good. Next example is the other way around. Okay? Because this whole thing only got 2 examples. But it's not that easy, you know. Okay? I want to write the whole question. What do you mean by that? This is different from example just now. Just now they already tell you it's decreasing. This one is you must show what? Show that it is increasing. That means I must show that dy dx is bigger than 0. You must show, no, it's not you assume. You understand? Just like discriminant, remember last year? Sometimes discriminant is less than 0. How many you got to show that it's less than 0 so that there's no solution? You understand what I'm talking about? Okay? Alright, now, first of all, okay, I let y be like this. Okay? Now, a lot of people will use the quotient rule, am I right? Okay, let's do dy dx. Let's practice quotient rule. What is it? Square the bottom. Fix the bottom. Differentiate the top. Become what? Square. Fix top. Differentiate the bottom. 1. So this is a 2x squared minus 6 over x squared. Did I make a mistake? Did I make a mistake? Wait, I fixed the bottom. Differentiate the top, correct? So text, wait. Oh, I think it's not going to be sick with it. Sometimes too bad, it's not too bad. So fix the top, differentiate the bottom. My mistake, right? Okay, so it becomes 2x squared minus x squared plus 6 over x squared. So this one becomes x squared plus 6 over x squared. That is easier. Everyone to say that. Okay. Now class, they say, show that the function this is increasing in the intervals less than 0 and bigger than 0. How come not equals to 0? May I know why? If x equals to 0, it's undefined. That means there's a asymptote down there. Do you agree? Correct. It's undefined. Okay. Now, for anything less than 0, hello? For x less than 0, now all of you look up. Even if x is negative, when you square it, it becomes positive, right? Plus 6 is still positive, right? Over something squared is still positive, right? So this is confirmed bigger than 0, am I right? Yes or no? So this implies what? Increasing function, right? This is to show, no? Not assume, no? Okay? Now, what about for x bigger than 0? This is even better. This is already positive, ma? This one is positive square, plus 6 is still positive, over something positive, this is still positive, right? So this will imply what? Increasing function. Everybody clear? But I find that this question is not well set. Because like that everybody also know. Okay? Wait till you do some of the questions then you'll realize that it's very difficult to prove. Everybody clear? Okay, so you look at the answer down there. Okay? Is bigger than 0 for x not equals to 0. Okay? Since not equals to 0, okay, I prefer you to write like that so that it's clearer. I show for both intervals. Everybody clear? Everybody understand what I'm saying? Okay. Now, then I want to ask you one question. Okay? Supposing my dy dx look up here. Supposing that my dy dx is this. Can you tell me whether my y is an increasing or decreasing function? Regardless of my x. It's increasing, right? Because no matter what is this nonsense, I square it, it's positive. You understand what I'm talking about? It can even be 0, doesn't matter. This one is defined for everything. Now, then what if I have this? This will be a decreasing function. Why? This is always positive. Then when you negative it, it's negative. So this is a decreasing function. That's why you must know how to read the algebraic expression. Everybody clear? Everybody clear? Now, when this is like that, it's bigger than 0 means y increasing, not dy dx increasing. Understand? Dy dx shows that y is increasing or decreasing. Clear? Okay, so if they say fx, then you got to go and find f prime x. Then you show whether this guy is increasing or decreasing, or gx g prime x. Kind of thing. Okay? So are we clear so far? Okay, good. What's the number on the content page now? What's the number on the content page now? 4, 5, 6, 7, 8, 9, 10. Now write 6. No, now when I ask is now write what? 7. Now write 7. Very good. Now write 7. So please go write 7. And today is also 7. Very good. Exercise 30.2. Increasing and decreasing function. Function are always short form fn. Okay, I'm going to give questions. Okay, questions. But I'm going to show you how to do it. Then until the last part, you go and do it. Will that be okay? Then after that, tomorrow come back, cannot do I show. Okay, but cannot everything go on now. That is very sad now. That's not a very sad story for this young, alright? Start on full scan. I hope I'm being very clear here, Okay? Now let's look at 13.2. 1b. Can we write down the question first? 1b. For each function, find an expression for dy dx and explain why y is an increasing function. Now, what's the question asking for? You are supposed to explain why is increasing, not assume y is increasing. Okay, let's write down the equation first. Y equals to x squared plus 2x for x bigger than 0. Write down this whole thing. what's the interval given for you? X is bigger than 0, right? Correct. All of you know that. For x bigger than 0, this one must be bigger than 0 also, right? 2 times a positive plus 2, or confirm positive. Okay? So therefore, okay, so this implies that y is an increasing function. Okay, class, you cannot just say like that. Don't show this. I said, it's obvious, you can see. I don't do, I also can see. But things that you must show me. You understand what I'm talking about? Okay? Alright. Now, next. Let's take a look at question number 2. 2a. For each function, find an expression for f prime x and explain why fx is an increasing function. Fx is negative 9 negative x. All of you go and find x prime x for me. Huh? What is it? Well, I differentiate this one. Well, the differentiate negative 9 is what? 0. What about this? Negative 1, right? Correct? So, since decreasing function, okay, actually this one don't need to say also decreasing. Do you agree this is actually a straight line? Do you agree that I can move like that? How do I sketch this graph? I'm revising a lot of things here. How do I sketch this graph? It's negative, right? And it cuts at negative 9, right? So it should be like this, right? And it cuts at negative 9, correct? Negative gradient, so slot this way. Agree? Yes or no? And the gradient here is negative 1. The slide is y equals to negative x, negative 9. Do you understand what I'm talking about? Can or cannot? Can, huh? Okay, good. So far, okay, no problem. Okay, question 4. Look at question 4. The function is defined by the equation y equals to 2x over x plus 1. Show that it is an increasing function for all real values of x except x. This is wrong, except for x equals to negative 1, not equals to. It's wrong. Did your textbook print x not equals to negative 1? It should be x equals to negative 1, except for x equals to negative 1. Because negative 1, then the denominator is not defined. Can you see it? Okay, print wrongly. Okay, never mind. Can you differentiate this for me first? And simplify. Don't leave it dangling. Use quotient rule now. I want it simplified. Okay. First thing, what do I do? Talking to you. What's the first thing I do? Square bottom. Then fix bottom. Differentiate top, right? minus x dot differentiate bottom line. Alright? What did the question say? It's an increasing function. Now, d1 x equals to 2 over x plus 1 square. Do you agree that x plus 1 square is always bigger than 0? For x not equals to negative 1. If x is negative 1, then cannot it's 0. Can you see? Yes, on the side you must say except for x not equals to, except for x equals to negative 1. Okay, except means you negate already. Okay? Now, if this is bigger than 0, that means 2 over something positive will be bigger than 0. You agree? Positive over positive must be positive. Okay? So, therefore, everybody okay now? Everybody okay now? About showing, this is called showing. I'm going to get rid of all this showing question already. Okay? Can you see I always say like that, I say something. Alright, now, then I want to warn you. If the function becomes like this, what will it be then? Less than 0, so what will it be then? Decreasing function. Do you understand? Do you understand what I'm saying? Okay? Alright, good. Can all of you now look at question 7? This is the straight way up. I like this type method because it's straightforward. You don't have to show. Can you see? They tell you. Agree or not? Okay, let's take a look at 7. Given that y is equals to 3x plus 4 over square root 2x minus 1, find dy dx and hence find the range of values of x for which y is increasing and 2, y is decreasing. They tell you increasing and decreasing. So first of all, let's go and find out dy dx first. Can you differentiate for me now? It's not that easy. But if you differentiate, you'll get some answer. Understand? Give you a little bit more time. Don't do increasing, decreasing first. Get the derivative first. Can I carry on now? Because if not, later I don't have enough time to finish this question. And this question is a bit tedious. Okay? Now, I want to write this one like this. Alright, like that. Because later on when I do, it's easier for me. Okay, but I also want to leave it in this form because when I square, I can see easily. Okay, all of you look up now. Don't copy. I'll leave it on the board. Promise. Okay, I also don't like to clean board. Now, square the bottom become what? Fix bottom. Differentiate top. Minus fix top. Differentiate bottom right. Half minus half times 2 right. A lot of you are careless when you do this differentiation. Okay? Everybody clear? I'm going to simplify this now. 3. Am I right? I'm going to show you something here. Of course, some people like to take out common factor and so on and so forth. But you take out until you cover. You take out until you cannot see anything, anyhow write the number. So I never do that kind of things. I will just write this. Then I do the inside. This one is gone, right? So it's actually over. Correct now? Everybody clear? Correct? Then I taught you something before, right? I said I want to get rid of this one. What do I multiply by? Top and bottom, right? Correct. When I multiply this, actually is multiplied by 1. Do you all agree? Okay, now let's take a look now. What is this times this? I'm left with 3. Am I right? Then I'm left with 1. Correct? Correct now. The top, bottom become what? Over 3 over 2, right? 1.5. So it's 3 over 2, right? Everybody okay? Now, this one I want to write it as square root cube. Do you agree? Do you agree it's square root cube? Okay, so this will become what? 3x minus 7 over. This will be my differentiation. Everybody okay? If you don't differentiate until like that, simplify like that, you can never see anything from it. Do you understand? Then is the next part that I'm worried. It's not that simple because this guy is a cube. If it's a cube, if this is positive, it's positive, you know. If this is negative, what will it become? Negative, you know. So tough already, can you see? Not like just now so straightforward. Okay? But I need to warn you, class. When I take square root of a number, this number must be positive, right? The inside. You cannot take square root of a negative number. Agree, class? Okay? Now, so first thing, are you okay until here? Are you okay until here? Okay, so I'm going to write this on the board now. Then I'm going to continue. dy dx is actually 3x minus 7 over 2x minus 1 cube, right? Okay? Now, let's look at part 1. They want the values of x, the range of value of x, but is increasing. Part 1. Increasing. Am I right? Very good. Now, look at this. First of all, this one has got to be positive first, right? The inside the square root must be positive first, right? That means I must have 2x minus 1 bigger than 0 first, right? Cannot. Equal to 0 also cannot. Why? Because equal to 0 become undefined. Agree? Correct or not? So I solve this linear equation, inequality. First of all, x must be bigger than half, right? Correct? I repeat that. For this for this denominator to exist, 2x minus 1 must be bigger than 0 first. Am I right? Alright, if not, you cannot take square root. So this is the first one. I haven't finished. If this is positive, this one also must be positive, right? For it to be totally positive. Okay, so must also be bigger than 0. Am I right? So okay. Now, so what's going to happen now? Do you agree that it must satisfy both? Then it will work. That means I must take the intersection. Okay, this one is done in step 3. Okay, now all of you look. This is half. Bigger than half is here. Why I put a hollow circle? Because it excludes. 2 and 1/3 is somewhere here, right? So, can you see the intersection is all the way? Correct? It must satisfy both. So, x must be what? Bigger than 1/3. For it to be increasing. Bigger than half is still no use. It must be bigger than 2 1/3. Agree, class? Do you follow, class? Can you see what I'm talking about? That's why I said this is a difficult question. Okay? Now, then part 2. Y increasing will imply dy dx is less than 0. Agree? Okay. Now look at the differentiations. Whether increasing or decreasing, denominator still must be defined. You agree with what I'm talking about? So the first thing is 2x minus 1 still must be bigger than 0. If not, you cannot take square root. Agree? So this one is still there. I just want to establish this. Are you clear? Okay, now, can you see that when I take square root of something, it should be positive, it cannot be negative. That's why I want to tell you now. Square root of 9 is 3. Not plus minus 3, this is already positive root. It's when you have x squared equals to 9. Then you have x equals to plus minus 3, because both also can satisfy. You understand? Square root of 9 is already the positive. Don't go and plus minus and reject. Understand? Okay, so this is done. Now, bottom is confirmed positive already. Can you see? Because of the square root. Now, to be less than 0, that means top must be negative, right? Agree? Since bottom is positive, top must be negative to be negative, right? Understand? So, 3x minus 7 must be less than 0. Agree? Everybody clear? Okay, so. Okay? Can? I'm talking to you. Can or not? Can, huh? Okay, now. I got to take the intersection again, huh? This is half. This is 2 1/3. Agree? All of you look up. Don't copy first line. Greater than half, hollow this way, right? This is what? Smaller than 1/3 will be here, this way. So, this is the intersection, right? Agree? So, what is the range? What's the answer? X between half and what? 1/3. Can you see what I'm talking about here? This is not an easy question, that's not easy. Do you understand what I'm talking about? Okay, and it doesn't mean that, wow, like that is that is even better because you know square root of something is always positive. Correct? Yes or no? Everybody okay? Everybody okay? Can, So no problem. Okay, so what is your homework? These three questions, 9, 11, 12. 9, 11, and 12. Stop the video, teacher. Will be your homework for today.